actually get a little bit warmed up. Let me just change this. And here we go. All right. So hope you're having a great time with Python. So Python was my first language that I learned. And it took a while. You start with hello world, and it just keeps tumbling from there until you start building bigger and more interesting things. And one of those bases is what we're going to be talking about today, which are data structures. And what I want you to think about when we're talking about data structures today is, remember, computers are just numbers. But if we want to do things or create things with code that sort of relate somehow to the world around us, we actually have to build something that makes sense to us, to humans, because we are the ones that need to use computers. And that's why when we're working with code, and it doesn't matter which language it is, we actually create these structures, because these structures, although we call them data structures, these are things that are going to be very common for all of us. I mean, they have a certain sense or a certain structure that has to do with how we tend to organize the world. And since we're talking about organizing, by the way, yes, this is today's background. And for those of you who guessed, yes, Kimetsu no Yaiba is the Japanese title of the anime, and the English title is Demon Slayer. But here's a question to get warmed up. Let's say you are coding a program to organize your collection of. So what is that collection of? If it's me, yes, it's my comic book collection. It's not with me anymore. It's very far away from me, but I still have my little program that has the whole collection, which I hope to see again sometime in the future. But what would you organize? What is your collection all about? So let me know in the chat, what would you be organizing with your Python program?
It looks like we lost Jack for a second. Let's just give him some time to reconnect.
So it seems I'm back. Let me just make sure that everything's working fine. Can you hear me?
Yes, I can hear you.
Yes? Okay, wonderful. Yeah, so something happened. I'm just trying to just to make sure that everything's fine over here. Yep, everything seems to be fine. So hopefully that won't happen again. I'm just hoping I didn't actually, it wasn't human error. All right, so black holes, who is going to, so are you talking about me disconnecting or about building a collection of black holes? I mean, that's an interesting collection, but interesting. All right, so let's get started. So today, we're going to practice a little bit about all of these data structures and how to build them and how we can use them. So the whole idea today is that you can differentiate between different data structures, specifically sets, lists, tuples, and dictionaries, and how to create them and how to use them a little bit. There's tons of other stuff you can do with them. There's a lot of particular things we can do with all of these structures, but that is something that you're going to have to learn slowly and one step at a time. So imagine that you are assisting a top-rated professor who's right now collecting applications for her research group. So you need to organize all this information one way or another. And right now, she's been putting everything in a Word document that every time something new happens, she just updates it. So far, we have 4 people that are interested in joining the research group. And your professor asked you to, please help her with a little bit of a Python, build a little bit of a program so that everything's a little bit safer. So it's not a Word document that's getting deleted and everything. But we can put this into code so that we can analyze it a little bit easier and faster. So far, these are our applicants. So we have Dr. Hannah Parker, who specializes in topology, applied mathematics, and number theory. We have Dr. Tim Neely, specializes in statistics, labor economics, applied mathematics, and medieval literature. We have Matt Hartford, software development, statistics, applied mathematics, and numbers theory. And finally, Dr. Mitua Patel, who specializes in quantum mechanics, general relativity, and quantum computing. So what we're going to do is, the first thing we're going to do is we're going to create an object to put these all these people together, or all these people inside some kind of an object. So in this case, we're going to use something called sets. So right now, I'm just going to copy and paste it just to make it easy. So to build a set, and this is important, actually, let me undo that. So to build a set, we use squiggly brackets. So these brackets are going to help you build a set. And sets you can build with anything. Sets can be, you can have a 1, 2, 3, and 4. You can have strings. So 1, 2, 3, and so on. Again, you just put all of the elements inside squiggly brackets and you separate them with a comma. And you can have different kinds of objects. You can have 1, 2, 3, and then the 3 can be an actual number. It doesn't matter. The only thing that's interesting, let's actually build a set. If I do this, 3, 3. So here's an interesting question. If I run this, I'm going to do print set. What should I get? I'm actually going to just call it st, so I'm not using the set function. So if I print this set, which is 1, 2, 3, 3, what would print out? Any ideas? Same. Well, actually, not exactly. So I'm going to run it, sets.py. So when you run it, this is what happens. This is what gets printed out. Nope, it's not an error. You get 1, 2, 3. So this is what we need to understand very importantly about sets. Sets, you can put as many things as you want. I can actually keep going and do 3, and then a 2, and then another 2, and then a 1. But if I build a set, sets cannot have the same object more than once. So it doesn't matter how I organize it or whatever happens. At the end of the day, it's only going to have 1, 1, 1, 2, and 1, 3. So I'm actually going to print it again. And as you can see, I only get 1, 2, 3. So that's the important thing. Sets can only have one copy of the same element. It can have multiple copies of something. So we're actually putting the specialties in a set for each of the candidates. So we're going to create one variable called Hannah Parker interests, Tim Neely interests, Matt Hartford interests, and Mitua Patel interests. And they're all going to be in, oops. And they're all going to be in sets. Now, the interesting thing with sets is that we can do other things with it. These are called methods. So every kind of structure has their own methods or things that we can do with them in particular. In the case of sets, we can actually add things to a set. So let's say, as we can see, in this case, we actually, Mitua Patel, we actually have only quantum mechanics and general relativity. If you remember, if we go up here, he also has another interest, which is quantum computing. Now, if we wanted to add quantum computing to Mitua Patel's interest set, all we have to do in this case would be to use the .add function. So methods are particular to structures or to certain objects. In this case, a set. So for example, if I have set, again, set 1, 2, 3, and I want to add number 4, I can just do st.add. So this is just like a function, but in this case, what it does, it adds another element to my set. And in this case, I'm just going to add 4. So, and again, I'm just going to print st. So when I run this, now it's 1, 2, 3, 4, because this added the number 4 to my set. So that's a way that we don't have to keep rewriting the sets. We can just add things. So in this case, we're actually going to add quantum computing to Mittua Patel. So I'm just going to write Mittua Patel interest dot add, and then inside the brackets as a string, because it's a string, I'm going to add quantum computing. And again, just to make sure that it works, I'm going to print Mittua Patel interests and see what happens. So how does the set know it's for Patel? Because I'm adding it to Mittua Patel. And the reason I know it's because it's here on my Word document. Remember, this is a Word document originally. So I'm adding it to Mittua Patel. And when I do this, now I get that it's general relativity, quantum computing, and quantum mechanics. So again, quantum computing got added to my set. So remember, the reason it knows it's for that I'm adding it to this particular set, it's because I'm adding it to the set that I want. So if I want to add general relativity to Mittua Patel, I actually add it to that particular variable that we already built before. So wow, Sapan, that's a great question. Can we just print everything in a print statement, like print all? No, you actually have to tell it that you want to print all of these variables. So you would have to print Hannah Parker, Team Neely, like individually for it to print the whole thing. You can print them in one, like for example, you could actually do something like, let me actually remove this one. It's already, no, actually, let me keep that one. I'm going to keep that one. Like, for example, you could actually do print this one and then Hannah just by separating with a comma. And that's going to print both of them. So one after the other. It's going to print first this one and then the second set. If st. So last step, that's a good one. So if I have, if st, my set is 4, 1, 2, 3, the best way to test how that gets printed out is to actually print it. So I'm going to print st and see what comes up. And again, it orders them. So this is another thing that happens with sets. Sets are ordered data structures. In other words, whatever you put in it gets ordered. I don't know if you noticed, but for example, quantum computing was added after quantum mechanics and general relativity. But when you print it out, you get general relativity followed by quantum mechanics. Oh no, that's fine. And quantum computing. Oh no, actually, general relativity pops up as the first item because it gets ordered. So again, in the case of sets, they are going to get ordered. Like for example, again, if I do, look, if I have a set that's 100, then 90, then 1, then 50, and I print it. Let me actually clear this. See, it gets ordered 1, 90, 100, and then 50. So it orders them. Generally, it should order them in a different way. Let me think why it's going doing the 50 afterwards. Weird. Can you change the order? Yeah, it tends to order things in a logical sense. But again, sets, the whole idea with sets is that it tends to do things A to Z. What are you getting? Interesting. So yeah, sometimes you're going to get a different order, which is interesting. But we're going to see that, for example, if you want, you can order them, but we're going to see how to do it in just a bit, just in case. Yeah, it's not going to guarantee the order, but it's going to have only one copy of whatever you have inside of it. And that's the most important part. So the important thing with sets and why are sets interesting is because we can actually do a lot of set operations. This is going to remind you of join statements in SQL, by the way. This is going to be important. It's going to be similar to inner joins or several kinds of joins. So this is going to remind you because it's all set theory. It's very simple, very similar, sorry. So we're talking about sets logics, and this is why if we have things that are going to be unique, that have no duplicates, we want to use sets because it's going to make our lives a lot easier. So for example, if we have two sets, let's say we have set A and set B. So let's say A is a set that contains 1, 2, and 3. And then we have B equals, let's say 3, 4, and 5. Then we can actually figure out what's the intersection between them. And interestingly enough, we can do it by printing A ampersand B. So this is sort of telling it A and B. And this becomes in sets, this operator is going to look for whatever is common between set A and set B. So if I print A and B right now, what should print out? What do you think? Think about inner joins. Correct. It should actually print out just 3. Oh, sorry. Now it sets logic. Sets logic.py. And there you go. It prints 3. If I had more numbers over here, for example, if I had a 4 here and a 6 here, it's going to be the same thing, but now it's going to print 3 and 4 because those are the items that belong to both sets at the same time. So that's one of the things we can do with sets, which is really cool. So let's actually figure out, now that we have this idea about sets or this element, and what happens if we want to figure out what's the intersection between the interests of Hannah Parker and Tim Neely. So in this case, I'm going to create a new variable. I'm just going to paste it here. So this is Hannah Parker and Tim Neely intersection. So it's going to be Hannah Parker interest. So it's this variable over here that has this set, and this variable over here that has this set. So my big question is, when I print the intersection of these two sets, what should I get? So what's the intersection? Let me actually open up this a little bit more. So what's in the intersection of Hannah Parker and Tim Neely? So yeah, one has topology, applied math, and numbers theory. The other one has statistics, labor economics, applied math, and medieval literature. So yeah, applied math should be the one that gets printed. And let's try that. So intersection of interest of Dr. Hannah Parker and Dr. Tim Neely is applied mathematics. So that's a cool thing that we can do with sets. Now, let's actually do a quick exercise. So find out what are the interests that Dr. Tim Neely and Dr. Matt Hadford have in common. And after you do that one, what are the interests that all 4 applicants have in common? So how would you do that? I'll give you a couple of minutes to do the code on that one, and then we'll do it together. Don't just tell me what it is. In this case, I actually want to see the code. Timer. Great work, everyone. There we go. And also remember, if you answer the first one, Team Neely and Matt Hadford, what would be the interest that all 4 applicants have in common? And what would be the code for that? I'll give you an extra minute. No, that's too much. So after you do Matt and Team, remember to do all of them. So what are the interests? What's that inner intersection between all of them? Yes, Gabriel, that's actually what's expected, and I'll tell you what that is in just a second. All right, so the first one, let's do Team Neely and Dr. Matt Hadford. So this would be MH, actually TN, Matt MH, intersection. This would be, in this case, I'm just going to take Team Neely interests, ampersand, Matt Hartford. No, yeah, Matt Hartford interests. So this would be the first one. And just in case, I'm actually going to steal this print and actually print it. This is not Hannah Parker. This is Team Neely and Dr. Matt Hartford. Okay, so if you print that one out, we should get their interests together. And Tom Neely and Matt, they have applied mathematics as well. Is that correct? No, I'm printing the wrong one. Sorry. Haha. I'm supposed to print this one over here. There you go. So it should be statistics and applied mathematics. So that's in this particular case. And if we look up here, we have applied mathematics in both of them, and we have statistics in both of them. So yeah, that's what we expect. Now, if we want to do all interests, then we do like most of you did. We're just going to take one by one. So we're going to take Hannah, and we're going to take Tim, and I'm going to comment this one out just so we don't get additional print statements. And we are going to take Matt. And finally, we're going to take Dr. Mitua Patel. So that would be all of them. And so I will print, and we'll do an F string. So all candidates are interested in and I'm just going to print all interests. All right. So if you did this one, once you run it, you actually get this called set and brackets. So that is what's called an empty set. It's just telling you that even though there are sets, they are looking at things and there's something there, it turns out that that particular intersection, there's nothing in it. Because there isn't, because if we look at it, especially if we look at Dr. Mitua Patel, quantum mechanics, general relativity, and quantum computing are not in anybody else's list of interests. So that is why it becomes really interesting. So we can actually very quickly, again, in this case, we can actually go one by one. But imagine if we had sets that had 100 items, 200 items, 1,000 items, and we want to see where they intersect each other. So this is also called an intersection. And sometimes we get this empty set. Now, the empty set is still information. It just says that there's nothing in that middle. There's nothing, even though there is things in the other inside of the other sets. And that is very important when we're doing set theory. And again, between all the other ones, we have applied mathematics. So if we actually try to see what are the interests of Hannah, Tim, and Matt, we would actually find that applied mathematics is something that they're interested in. Now, the other thing that we can do, and this is going to work with not just sets, but it's going to work with lists and with strings, which is interesting. That's for the future, is this function called len. So the len function, you call it by just len and then open in brackets, gives you what's the size of any set, any list, any string. When we're talking about strings, it's going to tell you how many characters it is. So how many items do we have in it? So for example, if I print len, let's do Hannah Parker interests. So what should print here? If we have Hannah Parker interests, what would be the length of the set? So again, the length is the number of items. So yeah, it should print 3. So let's actually try it out. And there you have it. It prints 3. So there's 3 items in that set. What about this set? If I print length of all interests, what should be the length of that one? So yeah, that one should be 0. So if I print that one and I actually get a 0. So it's, and there is a set there, there is something there, but the length of it is 0, it's empty. And that's very important. Think about the fact that empty, remember when we're doing null values, empty, does not mean 0. It just means that it's empty. There is a set, but there's nothing inside of it. And that is very, very important to understand. All right. The other thing we can do, by the way, is use the in, and this works for sets, which is very well. So imagine that we had let's actually, this is probably going to be a little bit more interesting. Let's say that we have a invited. So we have a set of people who are invited, and we want the set because we don't want to invite 2 people twice. So let's say that, I get invited and Fiona gets invited. And let's see, Sam gets invited. Oops. And Sam gets invited. And this keeps going on. And yeah, and Nude gets invited. So all these people get invited. And let's say that this list has 100 people. But we want to check to see, because there's so many people and I don't want to go through the whole list. I want to check if I actually added one person. I just want to see if that person is in the list. So in this case, what we want to do is we actually want to check for a particular name. So I can print, for example, I can print, is Fiona invited? This is just like asking, is Fiona invited? And when I do this, let me actually clear this up just to make it simpler. When I do this, it's going to say true. So this true means that yes, Fiona is in the invited list. So what happens if I check to see if Eric is invited? So if I run it and Eric is not in my set, it's going to say false because I haven't invited Eric. Oh, I missed Eric. So I need to add Eric to the list, and that's it. Well, I should actually, in this case, use the add function, but that's fine. The add method. But very important, this makes it very easy. So for example, we can actually check if general relativity is in some of the sets that we created before. So I'm actually going to copy these print statements. So one of them is I'm going to check if general relativity is inside Mitua Patel interest or if general relativity is inside Hannah Parker's. And in this case, I'm just checking if general relativity in Mitua Patel or general relativity in Hannah Parker. And this should print true for one and false for the other. So it's telling it, is general relativity and interest for Dr. Mitua Patel true? Is general relativity and interest for Dr. Hannah Parker false? So that's another really cool thing we can do with sets. And again, I want you to imagine having sets that have hundreds of items because, when we're doing data analytics, we don't generally just get, 2 or 3 things inside a set. We get hundreds, if not thousands of them. So this is a really, really good and fast way to figure out if something is inside a particular list or set. Well, sorry, inside a set in this case. Now, there's other things we can do with sets because we can compare them. Remember, just sort of similar to the joins, but with a little difference. So for example, we can actually figure out the differences between set 1 and set 2. So in other words, let's say, let's go back to our original sets. Give me just a second so I can. So let's go back to our, so we have set 1 with the numbers, just to make it easy to visualize, 1, 2, 3, 4. And we have set 2 with the numbers 3, 4, 5, and 6. So here's a big question. What is the difference, or in other words, what does set 1 have that set 2 doesn't? So in other words, what's the difference between set 1 and set 2 regarding set 1? So yeah, 1 and 2. What is the difference between set 2 and set 1 regarding set 2? Correct, 5 and 6. So what set 2 has that is set 1 doesn't, and vice versa. So the way we can do that, give me just a second. I forgot the specific for this one. Okay. Oh, and the other one is the symmetric difference. So this is actually called symmetric difference. So imagine the other one is the symmetric difference. So imagine we put together both sets and we see what's in this set and what's in this other set, but that it's not there together. So what would be the symmetric difference between set 1 and set 2? Correct. 1, 2, 5, and 6, because set 2 doesn't have 1 and 2, and set 1 doesn't have 5 and 6. So to do this, we're actually going to use this little, where did it go? So this little hat symbol. So let's actually print. Yeah, let's do an F string. Symmetric difference of set 1 and set 2 is, and in here we're going to do st1 hat st2. Let's clear over here just to clear up, and when we print this, we get the difference is 1, 2, 5, and 6. So again, if we want to make sure that we check what's outside or what things do not have in common with each other, we use the symmetric difference, and we use this little check. So for example, one more example, in this case with more text. Let's say if we wanted to check the symmetric difference between the interests of Dr. Hannah Parker and Tim Neely, what is their symmetric difference? Then again, we use the little hat between the two variables, Hannah Parker interest and Tim Neely interests, and then we just print it out. Now, if you look at it, here's Hannah Parker, and here is Tim Neely. So what would be the symmetric difference between these two? Yeah, the hat symbol is to get the symmetric difference between two sets. So all except applied mathematics. So yeah, so this is the only one that they have in common. So again, the important thing, the symmetric difference is the opposite of the join, is the opposite of what's inside both sets. So when I print this, when we run this code, we get that what they don't have in common is number theory, statistics, medieval literature, topology, and labor economics. So everything except for applied mathematics. So if we wanted to check, and this one's going to be a little bit bigger, so let me actually. So if we wanted to check what interest all of these people have in common with every other person, then we would have to run a few codes. So for example, and in this case, I just want to see how many interests they have in common. So HP plus, so Hannah Parker plus Tim Neely. And in this case, I'm just going to use the len on this new variable HPTN. And the same with others. So this is going to tell me how many interests they have between each other. Let's clear it because there's going to be a lot of print statements. And we have that between Hannah Parker and Tim Neely, they have one interest. Between Hannah and Matt, there's two. Between Hannah and Mitua, there's zero. Between Tim and Matt, there's two. Between Tim and Mitua, there's zero. And between Matt and Dr. Mituni Patel, there's zero as well. So again, these are all the functions that we can actually do with sets that are going to allow us to compare them together. And that's the cool thing about sets. They're very, very easy to compare. This is not going to be as simple. Like, so for example, this is something we can do with sets that we can't do with other data structures. So it's very, very important if we want things that are unique. So for example, anything that's that is only going to have one item, and even if there's multiple items, we can still do it. But we want to be able to compare them between each other. Sets are very, very good structures to do so. So you can use short form for names. But again, you remember you can name the variables whatever you want. But if these variables are already named Hannah Parker interest, I can short them. That's the name of the variable, and that's it. If I want to use a different naming, so for example, if I want this to be HP interests, I can do that, but I would have to change all of my variables to that. We can't do aliases like we do with SQL, or at least not easily. All right, so to wrap this up, and talking about sets, the other thing that we can do, and this is something that you can do with SQL as well, is the union. So unionizing two sets is just getting everything that both sets have. Now, the only thing is that we're not going to get any duplicates. So for example, if we go back, let me actually get rid of this. So if we go back to our sets over here, and we actually do a union of these two sets. So I'm going to print just the union without putting anything else, st1. And for the union, we use the bar, the straight bar, just like it looks like a big one, but it's not. So just a straight bar, st2, what would we get? That's a good question. So what is the union between these two sets? So yeah, this is good. So yeah, we get everything that is in these two sets without any duplicates. So when I print this, let's again clear this out. We get a set that contains all of the numbers that are in both sets, and it automatically gets rid of the duplicates. Because remember, sets cannot have duplicates. Sets can only have one item of whatever it is that we created. So again, if there are any duplicates, they're just going to get removed from the set. So here's an interesting thing. If I run the len of this set, what do I get? What's the length of the union of set 1 and set 2? Yep, it should be 6. And there you have it, 6. So finally, just to get back to our list of candidates, let's actually, if we wanted to check, the union between every single thing that the applicants have, we can just do it like this. So again, we do a union, and we just unionize using the bar of every single one of our variables that has the set of the information that we want. And this is actually going to print absolutely everything that they're interested in without any duplicates. So these are all the interests of all the candidates in one set. And that's it. That's what we do with sets. So here, questions about sets before we move on to lists. As you can see, sets are very, very useful, and we tend to use sets very particularly when we need some kind of a structure that can hold items without any duplicates. So just imagine if we're talking about lists of things that are particular, of IDs, of things that should not have duplicates. Those are great for sets. Where did you get 7 in len? We got 6. 1, 2, 3, 4, 5, 6 has a len of 6. All right. Questions? Any more questions? Any questions about sets? Remember, if you have any or you come up with any questions, just feel free to put them in the chat. Okay. Let's move on to something else. We have these 4 candidates, and these 4 candidates have some interest, which we have. And we set them up in sets. But there's other things that we're going to need from them. So for example, we're going to need contact details. So we asked all of the applicants to give us their contact details so we can contact them in case we need some information from them. But we asked them to order them in order of priority. So for example, if you have more than 1 email, give me 2 emails, but which one's more important, which is the primary email. Same thing with your phone numbers. So let's say that for this, we're actually going to use something called lists. Lists are similar to sets, but they are a little bit different. So let's actually think about how we build a list. So I'm going to do LST just to not use list. So the first thing is, instead of squiggly brackets, which was what we did to define a set, we're going to go use square brackets. So these square brackets are going to define our list. And the important thing about lists is that they are ordered, in a sense that no matter, depending on how we create them, that's how they get set. But here's the thing. What happens if I do this? Remember that in sets, it gets rid of duplicates. But lists don't work that way. So how many items are in this list? And what happens if I print it? Any ideas? So yeah, it's going to have 7 items. Now we need to change. This is lists.py. So as you can see, we get 1, 2, 3, 4. Well, 1, 2, 2, 3, 3, 4, 5. So it can have duplicates. But not only that, it can have a little bit of everything. So 4, 3, 1, 6, 7, 9. So first of all, when I print it, as you can see, the order stays the same. So it's indexed, and that's going to become very important. Being indexed is one of the most important things about lists, which we're going to see in a bit. And the other thing is that we can have all kinds of things inside of a list. So for example, I can have a 1, then the number 2 as a string, then 3 as a string, then we can have a 4 as a number, then we can have another list, which is interesting, that has the numbers 5 and 6, and the string 7. And if I print this, it's going to be printed exactly as I wrote it down here. So again, all of these items can be inside a list. We can put anything we want inside a list without any issues. Now, here's a question. This list in particular, if I print its length, because I can also use len with lists, how many items does this list have right now? Four or five. First I'm going to print it, and then we're going to count them. So it says 5. This is 1. This is 2. This is 3. This is 4. And this whole list with 3 items is 5. So the whole list becomes one object inside that particular list. All right. Let's go back to a simpler list. 2, 3, 4, 5, 6. Now, the important thing with lists is that they are ordered. And by being ordered, that means that they're indexed. So indices mean that the items keep their positions within the list. And we can actually access them because of that indexing. The only thing that we need to take into account, which is very particular, is that Python uses something called a zero index language. So that means that it starts counting at 0 and not at 1. So what index position does the number 1 have in this list? Exactly, that would be position 0. What about number 6? What index position does it have? Correct, it has position 6. So that becomes really important. But the reason this is important is because we can actually access them by using the index. So for example, if I wanted to print the number 2, what's the index for number 2? So what would be the index for this number? Yes, it would be 1. So I'm going to print, and then after the name of the list, I'm going to just put 1 inside square brackets. So what I'm doing here is I'm telling it I want the item at position 1 from this list, from this variable. So when I print this, it should just print the number 2. And that's what it does. It's printing number 2 because it's in position 1. Now, that becomes really, really, really important because, again, we can access any number or any position we want and figure out what's inside of it. So, for example, what happens if I do this? What does that print? If I print position 4 in list? Yes, that would be number 5. And what happens if I do this? If I print in position -1? So here's the cool thing. We can actually use negative indices. And what the Python is going to do, it's going to jump to the back. So -1 will be the last item. -2, the second to last. -3, the third to last, and so on. So if I print this, I can get the last item on the list. Very, very easy and very, very quickly. So one more example. So if I have this list, my list, that has 1, 2, 3, 4, 4, and I print list 1, what do I get? I get 2. Yes, correct. 2 in string, because this is a string. Now, here's another question. What happens if I do list 5? Oops. If I try to get the 5th element in my list, not the 5th, actually, the index, the item in position 5. So this is my list. The list is 1, 2, 3, 4, 4. What do I get if I'm looking for the one in position 5? So here's the interesting thing. When I run this, I'm going to get an error. And the error is called list index out of range. So again, this is 0, this is 1, this is 2, this is 3, and this is 4. There is no 5. 5 does not exist. And because there is no index 5, what I get is an error that says list index out of range. So again, there is a range. So again, same things happens if I do it on the way back. So for example, this is this. If I do it with negative indices, this is -1, -2, -3, -4, and -5. So I can actually go all the way to -5, and it's going to print 1. But if I do -6, I'm going to get the same problem. Now I'm out of range, and I get the same error, list out of range. So that's the important thing about lists. We can access particular items from the index, but the actual positional index has to exist. All right. Because I know we've seen a lot with the sets and we still have a way to go with lists and dictionaries, let's actually take a 10-minute break, take a breather, go get a cup of something, go get a drink, stretch your legs, go get a snack, and I will see you back here in 10 minutes. And again, if you have any questions, just drop them in the chat.
Beautiful. Thank you so much, Jack. We're going to start that 10-minute timer in just a second, and we'll do a duck race. So if anybody wants to throw, yep, let's watch the ducks race. Pick a number between 1 and 100. Thanks, everyone.
All right, so back to our lists. So the other really, really cool thing about lists is that we can do one thing called slicing. I'm actually going to go back to my original list just because it makes our life a lot simpler. So 1, 2, 3, 4, 5, 6. So this is just our list. It's just a bunch of numbers just to make sure that we understand the indexing better. So slicing has to do with what happens if I want to get a piece of my list, not the whole thing, just a piece. So for example, so to get a piece, you have to tell it which is the index that you want to start with and what's the index you want to stop at. But when you stop at that index, it does not include it. So again, it goes from the index that you want to start at, which includes it, all the way to the index that you want, but does not include. So for example, if I do this, so again, I do 1:4, I'm telling it, please give me all of the items from index 1 and stop right before index 4. So what numbers would I get if I print this? So this is the interesting thing. So what's at index 1? Number 2. Then it's going to go from index 1. It's going to include index 2. It's going to include index 3. And it's going to stop before index 4, which is the 5. So this should actually print 2, 3, 4. And let's just make sure that I'm correct. And there you have it. So what you're doing, it's slicing just gives you a sub list of the list that you're slicing. So let's do one more over here. What happens if I do, what happens if I do this, by the way? If I do 2, 3, what do I get? So that's an interesting one. Let's actually run it and see what we get. So that should only bring one number, which is going to be 3. So the number at position 2, at index 2, because remember, it's going to stop right before this last. Now, another cool thing that you can do with this is what happens if I do this? Actually, I'm going to do a 3 here. So I'm telling it to start at 3, and then I'm not giving anything afterwards. What do you think it's going to do? So I get one error. Any other ideas? Error. So here's the cool thing. Turns out that you don't get an error. What it's going to do, it's going to take everything from index 3, which is number 4, all the way to the end. And it works both ways. If I do it like this and I say, go here, it's going to go from the very beginning all the way to index 4. And again, 0, 1, 2, 3, 4, which is number 5. It's not going to include that one. So it's going to be 1, 2, 3. Sorry, 1, 2, 3, 4. It's not going to include 5. So this is how we do slicing, and it becomes very useful because we can get particular elements from a list. And how can we use that in real life? Well, let's go back to the idea that we have these 4 candidates, and the candidates all gave us 2 phone numbers in order of importance. So this one's more important than this one, meaning that this is primary, this is secondary, and 2 emails, a primary email and a secondary email. So, and again, same thing for all of them. So what we're going to do, for example, is let's say that we have Hannah Parker phones. So we have Hannah Parker phones, and we have her primary number and her secondary number. So we can print this. Let's clear it up so it makes clearer. So phone number of Dr. Hannah Parker, we have 2 of them. This one and this one, the primary and the secondary. Now, if we wanted to print out her primary phone, so for a preferred phone of Dr. Hannah Parker, what would I need to add here? How would I get her preferred phone number? Because we're in a list. Exactly. We can actually just go here and say, give me the number or the item at position 0. So now I can actually get her preferred phone number, and that's it. And that's what I get. I only get one phone number, which is this one right here. And that's really cool. We can get the information that we want. So again, that's her preferred one. Now let's actually do and enter her emails. So we have 2 emails as well. And if we wanted her preferred email, we would just add a 0 between square brackets at the end of Hannah Parker emails. And again, we just get her preferred email address, which is the first one. And that makes it a lot easier. So now what I want you to do is to translate Dr. Tim Neely's phone numbers. So we have Tim Neely's phone numbers. And I want you to print out his secondary phone number and his secondary email. And I'll give you a couple of minutes for that. So again, I want you to encode, just like we did with Hannah Parker, her Tim's phone numbers and Tim's emails. And I want you to print out his secondary phone and his secondary email. And extra points if you can give his secondary phone and email 2 different ways. "30 more seconds. If you need an extra, a little bit more time, please let me know and I'll add an extra minute." All right. So here's an interesting thing that we can do. Let's actually get rid of this one. So let's do Team Neely. So Team Neely, we had interests. This is going to be phones. So this is equal, and I'm making a list. So the first phone number is this one. I'm just going to, oops, no, that's Hannah Parker. It's this one. And the second one is this one over here. So again, we just added inside a list, and let's do Team Neely emails, and this would be equal. We also start up a list. So this is his primary email and his secondary email. Oops, that's not there. And there you have it. And then if we want to print them out, in this case, the secondary print Team Neely phones. And if we want the second one, we're going to do 1. And because that's the item in position 1, remember this is 0 and this is 1. And we're going to do the same thing for emails. Just going to change this to emails. Emails, and that should get our secondary email. Now this works. So again, we have 530, which is his secondary phone, and nilo@outlook.com, which is his secondary email. Now, this works perfectly if we know exactly where things are on the list. But if we know that we always have to get the last item on a list, and this is the secondary way to do it, we can just do it by using negative indexes. So again, -1 is going to grab the item at the very end of the list. And if I do this, I should get the same print exactly, because it's going to do the same thing, just in a different manner. Now, the difference is that if this list for some reason would grow and I still want the last item on the list, the -1 is always going to work. Okay, so great work, everyone. So yeah, we did that. So let's actually put all of the people's emails and stuff I can actually get rid of this. Let's do all of them over here. So we have all of these lists with all of their names, well, with all of the emails and numbers. Now, the next thing that we could do is to consolidate everything into a single directory. So for example, instead of having, one independent variable for Hannah Parker phones and one independent variable for her emails and one independent variable for her preferences, for her interests, we could actually just put everything together. And the way we can do this is by doing or by nesting stuff inside a list. So for example, if we just wanted to do everything for Hannah Parker, so we just create a new variable called Hannah Parker, and I'm going to create a list inside of it. And the list is going to have the lists that we already created. So the first one is going to be her phones. So I'm just going to add Hannah Parker phones. The second item is going to be Hannah Parker emails. And the third item is going to be Hannah Parker interests. So what's happening here is that I'm now nesting stuff. So I have two emails, I have two phones, two emails, and all of her interests. So here's an interesting question. So if I wanted to print everything, I could just, all of her information, I could just print Hannah Parker because now everything's in there. And this is what we would get. Boom. Now we have everything. See the two phone numbers, the two emails, and then the set with her interests. Now here's an interesting question. If all you had access, you knew how everything was built. If you were working with this Hannah Parker variable and you wanted to get her primary email, how would you get it? Just her primary email. Let's see if somebody gets this one. This one's a little bit trickier because remember, the email is a list inside the bigger list. That's a good answer, Dipesh. Very good answer. So this is what happens. If I do this, if I do Hannah Parker 1, this should give me her list of emails. And that's what it does. See, it's printing the list of emails. So it turns out that Python considers this that list. So I can just add another one. So Dustin, that's interesting, but actually no, you just need the one, and the one's going to print this. As you can see, the one actually has the list with her emails. And then after that, you can just add another number, which is a 0. So what it's telling it is go into Hannah Parker and go into item in index position 1. In there, because you already know it is, there's another list. And in that list, get position 0. So when we print this, I'm only going to get her preferred email. And that's it. And that's an interesting way. And we can keep going if you put lists inside a nested list, this is exactly what happens. So I'm actually going to take this and copy all of this and put all of this in here. So for example, now we already sort of did that, so it doesn't matter. So the thing is, we could actually just create an even bigger directory for everyone. So I could actually just do this. So I could create a directory, which is a list of lists. So again, in the directory, we have Hannah Parker and all of her information, Team Lily and all of his information. Same thing with Matt and Mituna. Now, if I did this, how would I get, let's say, Matt Harford's secondary email, secondary phone number? Let's get his secondary phone number from this directory. Any idea? Yeah, that's cool. So yes, you're on the right track. So whenever you're in doubt, you go one by one. So directory, So the first thing that, actually I need to print it. So print, print directory. And let's start with, how do we find Matt? So Matt is at position 2. So this is 0, this is 1, this is 2. So Matt is at position 2. Let's actually print that just so we can see where it is. What am I getting at? It's not defined. Give me a second. Look, I missed one. I missed Team Neely phones. Where's my Team Neely phones? I deleted it. I actually have it over here. Team Neely phones. That's what I'm getting an error. There you go. Let's do this again. Clear. There you go. So now I'm getting all of the information for Matt, because again, position 2. Now I need to get into phones. So phones is at position 1. But so it's in the first place, so it's at index 0. So let's do index 0 and let's print again. So again, these are his phone numbers. So if I wanted to get his secondary phone, I can either do -1 or 1. And boom, there you have it. So that's how we can work with lists, with directories, with everything. So I already gave you the solution for this one, which is this right here, which most of you got. That's great. Let me just check one thing out. Team Neely phones. It's a good question. Check out. I'll check it out in a bit to see what's missing, because it should work the way it's written, but there might be something missing with just check for typos. That happens sometimes. All right. So very interestingly, again, we can have all these negative indexes. This is the kind of things that we can play around with lists, but we're going to find in a bit of time that there are better ways to deal with this, or we have other options to deal with all of this information. So having said that, here's an interesting question. So which Python code returns the secondary phone number for Dr. Matt Harford, which we already did, 201, yes. Secondary phone number, yes, we did that. So yeah, that's the one we just did. So let's do another interesting one. So here's an interesting one. Can you get me Dr. Mituna Patel's first interest? So how would you get Mituna Patel's first interest? So let's see if this works. So if again, it's always great, especially when we're learning, to check one at a time. So let's do 3 first. That should be Mituna Patel's information. Yes. So first, we have a list with phone numbers. Second, we have a list with emails. And third, we have a set with interests. So that would be the thing in the third position. So that would be index 2. So that's his interests. And let's see if that actually works. And yeah, that's his interests. All right. So we actually get 3 and 2. What about the next one? So what happens if I do, in this case, 0, because I want his primary interest? And let's see what happens when I do this. So what's happening here? So I just got an error. It says set object is not subscribable. Any ideas what's happening here? So here's a question. What is this data structure called? The one that has general relativity, quantum mechanics, and quantum computing. It's a set. Guess what sets do not have? Correct. Sets do not have indices. Sets are unordered, unique items. In other words, they only have items that are not repeated. So sets and lists do behave differently. And we do not have indexes for sets. So again, I can get the whole set, but I cannot get just one item inside the set. So sets are good for other things. In other words, if we actually wanted to get this information, we would need to transform this set into a list. All right, so that's very important. So by the way, we could do it, but I don't want to confuse you. But let's actually do something more interesting. There's another interesting and very important data structure called a tuple. So a tuple is very, very, very similar to a list, but it's a little bit different. So let's actually build two of them. So I'm going to build the list equals, and this one's going to be 1, 2, 3, 4. That's fine. And I'm going to do a tuple TP equals. So to open up a tuple, you do it with regular brackets. Finally, regular brackets. Now these two are almost the same. So for example, if I print list 1, this should be the number 2. And if I print tuple, by the way, this one also has indexes. So if I do this, let me clear all this mess up. So I get 2 and I get 2. So again, they have indexes. The indexes work the same way. But here's the little bit of a difference. So it turns out that a list is mutable, meaning we can change the list. So after I create the list, I can actually do something called append, for example. Append, and I'm going to append, let's do 5. And then I'm going to print the list. List. So if I do this, guess what's going to happen? Correct. It's going to add a 5 to the list. So now the list is 1, 2, 3, 4, 5. That's great. I can also, apart from appending, I could also go list using indexing. I'm going to do list 3. So that would be the number 4, 0, 1, 2, 3. So positioned index 3 would be number 4. I'm going to say equals 10. So what do you think is going to happen now? What's the list now? Correct. It's going to change the 4 to a 10. And that's cool. All right. So what happens if I try to do the same to a tuple? So tp.append 5. And I'm going to print the tuple. Print tp. So what's going to happen now? What gets printed? Interesting. So yeah, I get an error. Tuple object has no attribute append. Okay, so maybe append doesn't work. Let's try and change something. So let's say that TP and again 3, which would be the number 4, equals 10. So what happens now? Let's run it, and I get another error. It says tuple object does not support item assignment. So what do you think is the difference between lists and tuples? Because the rest of the things that I do with tuples, like for example, print TP 1 all the way to the end so that it prints 2 to 4, that'll work. Look, it prints 2, 3, 4. So I actually, Dustin, love your example. We cannot, so lists are mutable objects. Tuples are not. They behave exactly the same as a list, with the exception that they are unmutable, meaning that we cannot change them. Once you create them, you can't change them. All right. So again, if I create them up here, there's nothing I can do to change the tuple as we go down the list. All right. But the list, we can actually change it. And that is the difference. So sometimes if you have a list of things that you don't want to change ever, you use tuples instead of lists. That is the big, big difference. But everything else, they work almost the same way. All right. So the last data structure that we are going to see today, can we convert a tuple into a list? Yes. So here's an interesting tip. So if you have a tuple equals, let's say 1, 2, 3, 4, then let's say list equals list. This is why I don't use the word list. So this is going to transform whatever I passed to this function is going to transform it into a list. So I do TP. And now let's do list. Well, first let's print it, just to make sure that it is a list. Actually have to do Python dictionaries .py. Did I write it correct? Yes. So now I can see square brackets. Now it's a list. So I can actually now append things to it. So I can do list.append, which is adding something 5. And now I should have a list of 1, 2, 3, 4, 5. So yeah, this is how you transform one thing into another. You can actually transform, and for example, you can actually transform anything you want. So for example, let's say list equals, 1, 2, 3, 4, 4, 4, 4, 4, 4. That's a big list. And you want to get rid of any duplicates. You can actually do st equals set list and print st. And that's going to transform this list into a set and remove all the duplicates. There you go. Now we have a set. And you could actually transform that set back into a list. So list2 equals set, list st. And now we print lst2. So by the way, that's a very quick way of removing duplicates from a list. So the difference between round brackets and square brackets, round brackets are for tuples, meaning they're unmutable, and square brackets are for lists that are mutable. That's it. That's the difference. All right. So finally, we have dictionaries. Now, I want you to think of a dictionary. So when was the last time you opened up a dictionary, by the way? Like an actual dictionary, you know, the one that has words and tells you what words tend to mean. 10 years, okay. But it turns out that this is very useful. So imagine that you had a list of words and you wanted to find a word, you know, it could take a while. But in a dictionary, if you want to know the definition of a word, this is ordered. So it has a key, which is the word, and it has and inside of it, it has a value or values, which is the actual definition of the words. And that is exactly how dictionaries in Python work. So again, you have, instead of ordering things just on a list with indexes, you actually create keys. And the keys can be anything you want. So for example, you can actually create a dictionary. Let's actually do, so dictionary equals, by the way, it's also created with squiggly brackets, just like the set, but there's a little bit of a difference. So the way we create it, let's say that we have an entry called 1, and then we do a colon, and then we add the number 1, then a comma. Then 2 has a 2 inside of it, then a comma, and then 3, I'm going to put a 3 inside of it. So now the order becomes irrelevant. Now I have keys. See, I have 1, I have 2, I have 3. These are keys. So now I can actually do this, print dic it's 2. And I get whatever value is inside the key 2. So I get the 2. So now I don't have to remember where they at. I don't have to know where they at. Now I just have key value pairs, 1 key and 1 value. And this, I mean, the next one, they don't even have to be in order. So for example, I could have 4 here, followed by a 4 and a comma. And still, it doesn't matter what order they have because I don't need to know their position anymore. I just need to know the key. And once I have a key, I can access the value. So yeah, imagine The key is whatever I want to call my key, the way that I'm going to access it. And then the value is whatever I want. And the interesting thing is that I can do it like this. Look at this. This is going to be my dictionary. It has 1. This is the number 1. 2 has the number 2. 4 has the number 4. Another 4 has the number 4. And 3 has a list. So I can put anything I want inside of it. And by the way, the keys can be almost anything I want as well. So the keys can be numbers, the keys can be strings. So it depends on how I want to do it. So if I print, in this case, my dict, and I want 3, I get the whole list. Sorry, 3, I should actually get the whole list. And the cool thing about it is that what happens if I do this? Let me do. And this actually works because my dict 3 is actually a list. So if I do that, I actually get the A, which is the one in the second position in my list. And this is exactly how we use these key value pairs. And if you think about this, this might be a better way to organize the list of candidates that we have, because it's going to be a lot easier to access the information that we want. Questions so far about dictionaries? Dictionaries can sometimes at the beginning feel a little bit more complex, but they become very, very useful very quickly. And by the way, if you've ever heard of JSON files use the dictionary structure. That's what makes them so incredibly useful. Dipesh, what do you mean by the comma at the end of dictionaries? Well, yeah, you can make it any way you want. And of course, you want the dictionary to actually make sense. And we're going to see an example of that today. So let's actually put everything that we've done so far. So we've already done this. So we have the sets for their interests. We have the lists for their phone numbers and emails. So instead of doing a nested list, let's do a dictionary. So let's actually see if this one helps understand dictionaries a little bit better. If not, I'll do another quick explanation. So what we're doing here is I'm creating a dictionary, big dictionary of all of the people that we have. So the first part of the dictionary, and this becomes interesting, is going to be phones. It's going to be the key. So the main key is going to be Hannah Parker. And inside Hannah Parker, I'm putting in another dictionary, as you can see. And the dictionary has the keys phones, which has her phones, emails, which has her emails, and the key interests, which contains her interests. So again, this is a dictionary inside another dictionary. But you're going to see how that makes it a lot easier to get things out. Then we have Tim, same thing. Tim is the key, and the value of Tim Neely is another dictionary that has phones, emails, and interests. Oh, you mean this comma over here? You're talking about this comma right here? Ah, give me a second. So, yeah, it turns out, well, you don't put it, but it's not going to make a difference either. If I'm not mistaken. Yeah, it doesn't really make a difference. So if you put a comma or not, it doesn't really make a difference. Sometimes programmers leave a comma because they're going to keep adding stuff to it. But the fact that there's a comma or not is not going to make a difference. This is not like SQL, by the way. So if there's a comma or not, it's not, again, not a big deal. It's going to do the same. Actually, let me just show you, just to make sure. Print, it's called dictionary dict. Dictionary. So again, this is without a comma. See, everything comes out. And if I put a comma in it and I print it again, that's the same thing. So this comma, whether it's there or not, it's irrelevant. This, again, some people just leave it because it's a way of saying, I'm going to add more stuff later, but it's not necessary. The only important thing is that if you add more things, you have to put a comma before it. So Python understand that it's the next thing. So here's the interesting thing. So now we have this dictionary. So now if I want all of the information about one of these people, I only have to put in their names. So for example, if I wanted all of the information for Mituna Patel, all I have to do is put his name in here because it's already set up by names. So again, Mituna Patel. And when I print this, it's clear. I get all of his information. I get his phones, I get his emails, and I get his interests. If I want to get his phone numbers, I can just go and ask for his phones. So this is why dictionaries become a lot easier. So now I actually get his phones. If I want his primary number, because I know phones is a list, I can just do this. And now I get his primary phone. So this makes it a lot faster because now I don't have to know almost anything about the structure except for the keys. All I need is the keys, and then I can navigate the dictionary a lot easier. So again, I can go and just get the Mituna Patel emails or phones, in this case, let's say emails, to get his primary email, and boom, I get his primary email. So yeah, dictionaries are very, very, very useful, especially because inside of them, we can put other structures. So again, we can put structures within structures and still make it simple and easy for us, as long as we remember the keys. By the way, if just in case, you can actually just print the keys. So if you don't remember the keys, use the dot keys and with brackets. And then as you can see, it's going to tell you what are the keys for that dictionary. So you don't have to remember them. You can just ask it for it. What is the difference between the directory and dictionary? The directory as in the phone directory? Jeffrey. Well, the directory is just a dictionary of phones. That's what I would call it because it has the same structure. But at the end of the day, I want you to think about the structure. And the dictionary structure means that you have a key. In the case of a directory, the business name or the person's name, and the value is the phone number or phone numbers if you have more than one, or addresses. It can have many other things. So here's a question. What does this Python code return? If I print dictionary dict, Team Neely, phones 1, what do I get? And you can try it out if you want. So you should get his secondary phone number. Yes. So let's try it out and see what this prints out. Boom. Let's clear this because it's getting really messy very quickly. And yes, we get 503-832. So this is the right answer. So again, as you can see, with dictionaries, we can organize it to make it a little bit simpler. All right. So write code to display Dr. Matt Hartford's interests. And what kind of data structure is the resulting output? That's a really good question. So I'll give you a couple of minutes. So again, using this dictionary dict that we have over here, write a code to display Dr. Matt Hartford's interests. And what kind of data structure does it output? Yes, Pankaj, I'll be happy to explain it in about a minute. Actually, about 30 seconds. All right. So yes, in this case, as we can see, it makes it a lot simpler to navigate. So we're looking for Matt Hartford, so dictionary dict. And inside here, we get Matt Hartford. Where's my Matt? Okay, Matt Hartford. There you go. And then inside Matt Hartford, these I am looking for interests. So I get interests. Oops. I just get the interests. And then let's see if that works correctly. And yes, I get a set that has numbers theory, software development, statistics, and applies mathematics. So just to go a little bit, so this dictionary, so this is a dictionary. What we're building here is a dictionary. Let's actually take it one step at a time to make our lives easier and explain again, just in case. So this is a dictionary that contains several things. Let's actually just do it for Hannah. I'm calling the dictionary a directory just because it's a directory of information on people. So let's just call this one directory 2, just in case. So what we're doing is I'm opening up the dictionary. Again, we use squiggly brackets to do a dictionary just like we did with sets. Now to start with, I need to create a key. So this is how I'm going to look for stuff. So again, think about how a dictionary works. So it has words. In this case, this is a directory of people, but the structure is still a dictionary. So I'm going to do Hannah Parker. So Hannah and Parker. Okay, so that's the name of the key. Now, the value of the key can be different things. Now, in this case, because I have all this information, I have her phones, I have her emails, I have her interests. Instead of just putting one thing, I want to put all of it inside of it. I could put a list, but then I would run into put it using a nested list again. So what I'm going to do is the value, which could be 2, could be 3, could be anything. But in this case, I'm going to do another dictionary. So it's a dictionary inside a dictionary. And inside this secondary dictionary, I'm going to have her phones, which are going to go to Hannah Parker phones, which again, remember, this is a list that we already built before. Then a comma, and then we have her emails. And her emails are going to contain Hannah Parker emails because we already built this before. And I'm going to do another comma. And finally, again, this is the key is going to be interests. And the value is going to be the set that we created before called Hannah Parker interests. So this is how I built it. So again, this is a directory that has one item and inside, or one key. And inside that key, there's another dictionary, in this case, with 3 values. Once I'm done with this one, I can actually build the next one. The next one would be Team Neely. I'm just using different. So Team Neely. So that's the key. So that when I look for something, I can look for Team Neely. And inside of it, again, I'm going to put another dictionary. And in this dictionary, very particularly, are going to be the phones. Again, but in this case, instead of having Hannah Parker phones, I'm going to put Team Neely phones. Oops, forgot the comma. Then I'm going to have the emails as a value, as a key, and the value is going to be Team Neely emails. And finally, I'm going to have his interests. So interests. And the value is going to be Team Neely interests, which again, we already had before. So this is how you start building the dictionary. It's piece by piece. And again, this is one big dictionary that's going to end up having 4 people. But inside each of those keys, there's going to be another dictionary with 3 keys. One for the phones, one for the emails, and one for the interests. So again, as you start putting this together, it makes it a lot easier to find out the stuff that you need. So for example, afterwards, if I print, I want directory 2, and I want the information on Team Neely, I can just look for Team Neely. Neely. Let me clear this. And this should print all of the information that I have on team, his phones, his emails, and his interests. Or if I'm interested in one of those in particular, like for example, his phones, actually it's phones, then I just ask for the specifics of his phones. And by the way, it seems like it's a little bit more complex, but this is how lists, directories, like when you go into a website and you look for some information and just look for that name, this is how they're built. This is like the basic, one of the basic structures of how those things are built. Pankaj, was that clear? Is it now a little bit clearer how we build dictionaries? So the three structures, actually, today we went through a few structures. Let's actually do a little bit of a thing. So we have sets. So let me actually, where's my annotate? So we have sets. So to create sets, we use the squiggly brackets. Sorry for my writing. I know it's not great. Now, the importance of the sets is that the order doesn't matter. They're unordered. So there's no indices. But you can store elements and it cannot have any duplicates. So a set can only have 1, 1, 1, 2, 1, 3. It can't have multiple copies of the same thing. The advantage of sets is that they're very easy to compare. If you want to compare whether this set has the same items as the other set, again, we use the ampersand, or we can use the bar to get the differences between the two of them. So, sorry, the unions, or we can use the little hat to get the differences between them. So they're very easy to do comparisons. And we use the squiggly brackets. Now, I'm putting them here because for dictionaries, we also use the squiggly brackets. Now, the big difference is that when we're building sets, inside the squiggly brackets, we just go one item, item 1, item 2, item 3, etc. When it comes to dictionaries, we actually do key, whatever the key is, then colon, then the value, then a comma, then the second key, colon, the second value, and so on. So that's how Python knows when we're using one or the other, just because of this structure versus this structure. So that's how it knows one is a set and one is a dictionary. Now for lists, we use the square brackets. Now, lists are ordered item sets. They can have any kind of item, any kind of object inside of them, but and they have indices. So a few examples. Sets. We use sets when we want to compare things. So just to give you a few ideas, as I mentioned before, let's say that you want to create a list of people who you are inviting to a party. So, most of the time people have unique names. I mean, there are exceptions, but most of the time they have unique names. So you put them in a set so you don't have any duplicates. Also, because you can check whether they're in or not. Also, you can check between two lists of people, let's say class 1 and class 2, and see if there's, or for example, Python class and SQL class, and see whether there's people that go to both classes and which people go to only one class. So in that case, you might want to use a set. All right. Now, lists, we use them for almost everything. So we use them to collect items, all kinds of items, and you're going to see that these are very, very common. So lists are very, very common in when we're programming. They are ordered, meaning that we can sort them, we can organize them, we can add things to it, we can reassign things. So we can use them for almost anything. So anything that you can think of that you're going to build a list for, you can use it. Tuples. Tuples, we use regular brackets to build them. Now, tuples and lists are exactly the same with only one difference. Lists are mutable. We can change them. And tuples are unmutable, or like somebody called them, they're stubborn, meaning that once you create a tuple, that's it. That's the tuple forever. So to give you an example, if you're building something where you want to add things, let me actually, so let's say that you're creating a video game and the video game has a list of powers and the list of powers can grow. Your character can keep getting more and more powers. Then you would use a list because you want to add things to that list. Now, let's say that once you create your character, you assign a certain amount of powers, and that's it. That can never change. So in that case, you would use a tuple. So again, it depends whether you want to change something or whether you don't want to change something. But apart from that, tuples and lists act exactly the same. And finally, dictionaries. Now, dictionaries, we use them for everything. That's why I asked you about if you've ever seen JSON documents. So JSON documents are a particular way of storing data. And as you can see, they're very helpful for a lot of things. So imagine if you wanted to say, well, I want to collect a list of websites. And in that list of websites, I want to know what the website is about, what are the most important keywords, and how many people view the website, how many people have viewed the website so far. So now you can think about a dictionary. So you have a dictionary where the key is the name of the website. And then the value is another dictionary that has, for example, as we saw today, we have the information about what is it about, then a second key that tells us what the keywords for the website are, and then which might be stored in a list, for example, because we want to change that. And then a third one that has just an integer of how many people have visited the site so far. And that's it. And again, you can think about thousands and thousands of uses depending on what collection of items you need, what collection of objects you need to do. The when and where, it depends. So I've seen people, for example, use lists instead of dictionaries, and they're very successful with it, even if they're using nested lists, because for what they're doing, it works. So it really depends on what you feel more comfortable with and what exactly you're trying to build, how you want to access that information. I see people, for example, there's a whole concept called functional programming, which uses a lot of tuples because they want the information to not change. So there's a lot of things that we can do. You can, in SQL, using the browse date or browse structured, can you look at the sets, lists, and dictionaries that you create? Like you can in SQL using browse date or database structure tab. So not sure if I understand the question, James. It seems like it's a really cool question, but I don't completely finish understanding it. So are you trying to talk about the views or the tables that we can create using SQL? Is that what we're talking about? Yeah, I'm getting a few replies. Let's see. Okay. Yes, you will have that stuff soon. And for example, if you're thinking, this is a very important one. If you're thinking, what is the structure for tables? It's called a data frame. And we're going to learn how to do that with pandas a little bit in the future. So don't stress out about it. We can actually work with tables as well. We're not going to make you build tables using lists and dictionaries. That's too messy.